that way. Now, if you have a coil moving, so the first thing you needed to realize, if there's a current flowing in this wire, there's already a magnetic field created using your right hand rule with your thumb pointing. So you're going to point your thumb in the direction of the current, and then there's going to be a magnetic field going around. So the only way you can show that is that on this side it's coming towards you, so it's going to be, oh man,
coming out the paper, so it'll be a dot, and the other side will be a cross.
So here it's going to be dots coming out of the paper, and on the other side it's going to be crosses. But what you must remember, the further you go from the wire, what's happening to this magnetic field?
It's getting stronger.
Further.
That's also another question I have, but no, so it should be getting weaker.
No, so the further you go, the less dense the field gets. So these dots are going to get further and further apart the further you go, because the field gets weaker the further you go. Remember when we would normally draw it, we would draw the circles, and the circles will go further and further and further apart.
Yeah.
Are you with me now?
Yeah.
Okay, so those dots will go further apart, and also the crosses will be close, and then they'll go further and further. Close, close, further, further. Okay, I'm just going to do this a few times. Okay, now if you have a coil in this, so now we place a coil in this magnetic field. So so they give you something like this.
Yeah.
Okay, so at the moment you've got dots coming out. Yeah, so for one of those options, it's moving towards the wire. Sorry, I'm just going to close my door. Okay, so the dots are coming, so it's moving towards the wire. So what's happening now, so think about it, it's Lenz's law and Faraday's law in one.
Yeah.
Because what's happening if it's moving closer? Are these dots getting more or less?
More.
They're getting more, and according to Lenz's law, you're going to try and decrease them.
Yeah.
So you're going to try and make crosses. So you're going to decrease them by making crosses. Now put your finger in the direction that the crosses go, so into the page.
Yeah.
That shows you that there will be an induced current in this loop going around like this. So it will be clockwise.
Okay, I'm with you.
If it's moving away, so there's one option where it's moving away.
Yeah.
So if it's moving away, you also have dots in here. But if it's moving away, are these dots decreasing or increasing?
They are decreasing.
They are decreasing, so you're going to try and make more.
Yeah.
So if you want to make more, you're going to form more dots. If you now put your finger in the direction of the dots, coming out of the page, it's going anti-clockwise.
Okay, and that's B.
And then there was another one on this side that was going this way. So there's no change in flux because it stays in the same place. So the crosses that it has will still stay the same density. Remember, change in flux density. So there's no change. And then the other one that is moving.
Yeah, just moving right that way.
Yeah, so that means the crosses are decreasing. So you want to increase the crosses, which means again it's into the page. So it's going clockwise again.